Covalent bond, or bond, is a sharing or overlap of electrons between two atoms, the most basic units of matter. As we all know, life is one of, if not the most complicated topics in all of science. The basics of life, however, begin with a simple element known as carbon. Carbon is the sixth element of more than 100 elements in the periodic table. But carbon is much more than just a number on the periodic table. Carbon is actually the building block for all life, and for good reason. Carbon has 4 valence electrons. 1, 2, 3, 4. That is, 4 electrons in its outer shell. This allows the carbon to form up to 4 covalent bonds with other atoms. And beginning with a single bond, carbon can form single or double bonds in thousands of different ways, and consequently is able to construct living organisms by bonding in such unique ways an infinite number of times. A carbon atom is hardly ever just a carbon atom. More often than not, a carbon atom will form a bond with at least one other atom. For example, the starting point in organic chemistry, or the study of organic compounds, is methane, a carbon covalently bonded with 4 hydrogen atoms. This is more commonly known, however, as a hydrocarbon. The study of how carbon bonds with different elements and the structures it forms is the basis for organic chemistry. The first way to change the structure and function of a carbon-based molecule is to lengthen the hydrocarbon chain. That is, add another carbon to which more hydrogen atoms can bond to. With the addition of a single carbon, methane becomes ethane, an entirely different compound. And if you go one step further, ethane becomes propane, with the addition of a third carbon atom and 3 hydrogen atoms. Along with adding carbon atoms to a hydrocarbon chain in a linear fashion, carbon atoms can also be branched off of existing carbon chains. So what was once propane now becomes methylpropane, as it has a methane molecule branched off of a propane molecule. The next way to change a carbon-based molecule is by changing the bond type involved in a hydrocarbon chain. By making a single covalent bond in ethane a double covalent bond, you suddenly reposition the 2 electrons that were once used to bond with 2 other hydrogen atoms, and again create an entirely different compound than before. Ethene. Another effect that a change of bonding can have on a molecule is seen in the addition of a double bond in a phospholipid. By adding a double bond to the hydrocarbon chain of a phospholipid, you suddenly change the structure of the chain by adding a kink in the chain, as you can see here. This kink can play a vital role in cellular life, as it prevents phospholipids in the cell membrane from packing together too tightly, and thereby restricting the intake and outtake of necessary nutrients to the cell. Having covered the number of bonds, types of bonds, and addition of carbon atoms, all as factors affecting the structure and function of carbon-based molecules, we can now talk about something called isomers. Isomers, by definition, are compounds with the same number of atoms of the same elements configured in different structures. For example, the compound hexane can either be straight, a hydrocarbon chain, or it can be a hydrocarbon with a branching methyl group right here, and this is called isohexane. This simple change in structure again changes the molecule structure, which is very obvious, but it also changes its function. Functional groups are a few specialized groups in organic chemistry that can be added on to pre-existing organic compounds. Functional groups, by definition, consist of modules directly involved in a chemical reaction. Functional groups consist of the amino, carbonyl, hydroxyl, phosphate, and sulfhydryl and carboxyl groups. The addition of these functional groups onto a compound again changes the compound structure and function. Take ethane, for instance, and add a hydroxyl group onto it, and suddenly it becomes ethanol, the alcohol found in most alcoholic beverages. Ethanol.